So in this problem here, we've got a wedge of mass 3 kilograms resting on a smooth horizontal table, makes an angle of 45 degrees and a horizontal, and a particle of 1 kilogram is placed in the face. So just a general gist of it, we'll just draw a quick diagram here. That's what the wedge will look like. And then we've got a particle here on the wedge, like so. What we know is that this is 45 degrees. And we're told this is 1 kilogram. And this one here is 3 kilograms. What's going to happen basically is that this particle is going to slide down with an acceleration we'll call B, while the wedge moves to the right with an acceleration we'll call A. Now, with this you're going to break it down to 3 components. You have to deal first off with the accelerations here. B and A aren't in a good situation the way they're there. What we want is, instead of A here, we're going to change it to be both perpendicular and parallel to the incline. So I'm going to do that now. So we have B is down this way, parallel to the incline. A at the moment is like that. Instead of like that though, I want A to be this component here and this component here. So I'm going to change A like that. I'm going to call that just a different colour so that it's distinguished from it. So instead of A going across the way, we're going to have A up like this and across like that. This angle is 45 degrees, that's the adjacent. And remember, the sine and cos of 45 degrees is 1 over root 2. This would be A cos 45, and this would be A sine 45 degrees. This vector here is B. Second thing we have to really worry about is the fact that we've got this mass here. Now, gravity is pulling it down that way. We don't want it like that. We'd way prefer if the force was perpendicular and parallel. That and that. Again, this angle here is the same as that angle there. So we know that the force perpendicular, or we do parallel first. So the parallel force is this one here. Force is always mass times acceleration. Now this component of force here, we're told that's 1g. So I'm going to redraw that triangle so we can see it there. That's g. And then we've got this component and this component. That angle is 45 degrees. This is 1g here because it's 1 kilogram. This will be g cos 45. This will be g sine 45 degrees. So the force, if we go with parallel first to the incline. Force parallel is g sine 45, which is g over root 2. That's equal to mass times acceleration. Well, the mass is 1. The acceleration here is B minus A over root 2. Just highlight that force there is equal to the mass times this acceleration minus this acceleration there. It's equation 1. Equation 2 is perpendicular to incline. Now, perpendicular to incline, I'll use a different colour to highlight it. We've got that force there, and we've got this. That's the force, and that's the acceleration. It's quite an easy one. We have g cos 45 degrees is the force equal to mass times acceleration, so it'll be 1 times a sine 45, which is 1 over root 2. So what we've got here is, that's g over root 2 is equal to a over root 2. Sorry, and then I should have drawn the force diagrams here. I'm rushing it a bit, I'm making mistakes. If I draw the force diagrams first, you'll see that I'm missing a vital force for that second one. That particle, we have to include or as well. So I'll just make a little bit of room there and do that now. So the particle is like this here. The forces at play are, we've got gravity down. The crucial one you don't want to forget is or is back up there. Or, that's 1g there. So this force here has to be included. That force has to be included with this calculation here, because it's that minus that is equal to the acceleration times the mass. So I have to include minus or there. Finally, the third equation comes from the wedge. With the wedge, what we've got is, and I'll draw it separately here. The wedge looks like this. The force that's going to push the wedge along is the reaction force here. Instead of writing it like that though, we're way better off looking at it one component down and a component across. So that's or. This here is the same as that angle, 45 degrees. So this will be or cos 45. This will be or sine 45. So for this one we have the acceleration is, for the wedge, is just a across. So for the third equation we know force is mass times acceleration. The mass of the wedge is 3 kilograms. The force is or over root 2. Or sine 45 is equal to 3 times acceleration, which is a. Force is mass times acceleration. Divide both sides by 3 and we get a is equal to or over 3 root 2. I'll just highlight our equations. We've got 1, 2 and 3. Now, 3 can go into 1 there. We can get rid of or, and substitute it in here, and then we'll have a. If we have a, then we can work out b from this one here. So we'll just do that then. Taking equation 3 there, what we get is that or is equal to 3 root 2a. Substituting into equation 2 then, we get g over root 2 minus 3 root 2a is equal to a over root 2. That's 3 into 2. Multiply across by root 2 and we'll get g minus root 2 times 2 root 3 is 6a is equal to a, or g is equal to 7a, or a is equal to g over 7. Now, taking this and subbing into 1. So, subbing, we get g over root 2 is equal to b minus g over 7 root 2. What we're looking for is b, so multiply or bring that across. We get b is equal to g over root 2 plus g over 7 root 2. Multiply this fraction above and below by 7, same common denominator, and we get b is equal to 8g over 7 root 2. Now, we've got our equations, we've worked them out. This question asks for just a little bit more. I was meant to call b f. So we've used b instead of f there. We want them both in terms of I and j. And then by adding, show that the actual acceleration of the particle is a magnitude of 5 over 7 g. Okay, we'll quickly take b there. We know the magnitude of b is like that there, but we also know that this angle here is 45 degrees. So, to get this in terms of I and j, we need this vector here and this vector here. Now this will be, we know this is 8g over 7 root 2. This will be 8g over 7 root 2 times cos 45. It's always the adjacent. Multiply the length by the cos of the angle. This is 8g over 7 root 2 times sine 45 degrees. They both work out to be 1 over root 2. What you'll end up with here is, if you put that into your calculators, you'll end up with 4g over 7. And this will also work out to be 4g over 7. So, b as a vector in i's and j's, well, it's going to be minus and minus because it's going both negative directions, isn't it? So it's going to be minus 4g over 7i minus 4g over 7j. A is a little bit easier. A is just equal to plus g over 7i. Isn't that what A worked out to be? G over 7. And it's going to be just plus g over 7i. So the total acceleration is A plus B, which will be, adding 1 to this, we'll get minus 4g over 7 plus g over 7i minus 4g over 7j. It's adding A and B. This will become minus 3g over 7i minus 4g over 7j. And the magnitude of this will be equal to the square root of this squared, which is 3g over 7 squared plus 4g over 7 squared, which will be equal to the square root of, that'll be 9g squared over 49 plus 16g squared over 49. Should be equal to the square root of 25g squared over 49. We can get the square root of all these things and we get 5g over 7 as in total acceleration.